everyone. So, how was your week so far? Good?
How about you?
It's busy. Like, I have classes every day. And this is so loud. Okay, so we talked about relational model. So we started with introduction to database. Then we discussed the ER modeling and how we actually design an ER model using ERDPlus. We learned what are entities, what are attributes, and what are the relationships. So just as a review, for instance, I use the example that we use in the class for the student registration system. We said that sample entities could be like a student, instructors, courses, and so on. And then, so basically entities are just any like person, any object, like a person, place, or anything that you would like to keep track of in your database. So whatever that you would like to store some information about it. So for instance, we would like to store information about students, about the courses, about the instructors, departments, and so on. So we are going to have these entities, which are going to be our tables later. And then for each of these entities, we define attributes, which were the characteristics of those entities. Like for instance, we talked about what could be the attributes for the student, like a student number, name, and so on, and for other entities as well. And for the relationship, we said, okay, later when we want to get the queries, we may want to know what courses, for example, a specific student was enrolled in, right? Or for instance, we may want to see which department each instructor is working in, who is the manager of a specific department, or for instance, how much was the enrollment for each course. So like for these kind of queries, we want to access like maybe to multiple entities or tables. Sorry. So we need to also connect these tables through relationships, right? So we said that, okay, we need to have a relationship between some of the entities. For instance, we may want to have a relationship between a student and a course because we want to see which courses each student takes. Now, what are the type of relationships that we were talking about? What was the types? Anyone? Oh, yeah. One-to-one, one-to-many. Yeah. Can you also provide an example for like any of them?
Products and suppliers.
Each product, each supplier, assuming that can supply many products, but does each product supplied by one supplier? Yeah, but for your business rule, also try to use the one that makes more sense, okay? So like, for instance, even for the, so you may assume, like this way, you may assume one-to-one relationship for all the entities, right? Because you say, okay, I assume that each supplier can only produce one product and each product is only produced by one supplier. But that is not acceptable. So you, especially for your project, because you already have a database, like an example of a website, so you see what are the possibilities there. So you see, for example, if you as a, let's say, a customer or user can order, for instance, several products, right? So in that case, you cannot assume that, okay, each user is only like, I assume that it's only ordering one product. And we also talked about many-to-many relationships, and we said, okay, whenever we have many-to-many relationship, we would like to get rid of that by using an associative entity. And why do we need to do that? Why do we need to get rid of many-to-many relationship? What is the problem with having a many-to-many? Like, for instance, if I'm going to keep the relationship between the student and a course many-to-many, what happens? Let's say you have a table with the student information, and then you have a table with like information about the courses, and now each student can take multiple courses. Each course can be taken by multiple students, right? So how would you like to design that then? Are you going to put like for each student? Because a student number in the student table is unique, right? That's a primary key. So a student number should not be repeated here in the student table. Sorry, I don't have a marker. So you say, okay, either you have to store multiple courses for each student in the student table, right? Which is not acceptable by the rules that we have for relational databases, and it's against the atomicity of the data. Or you say, okay, I have the course table. Now for each course, I'm gonna store multiple students that were enrolled in that course. Again, that also violates the data integrity, right? So for these reasons, we need to get rid of that many-to-many and breaks it into two one-to-many relationship. And we said we can do it always with associative, like introducing associative entity, because, thank you so much. Because we say, okay, so for, here we had the student, and here we have the course, and so we had like at the beginning, we had a many-to-many relationship here, because we said each student can enroll in like many courses, and each course can have many students enrolled in that course, right? And when later you are designing your tables, here you have the student ID, right? Name, and so on. And here you have the same thing in the course table. So you have the course ID, you have the course name, maybe a description of the course, maybe the schedule of the course, and so on. But for now, I just want to like focus on the main entities. Here, this is your primary key, because this is unique, and this is also primary key here in the course table. Now, let's say student ID 123, which is, I don't know, Mona. And there are some courses here like 3421, like 3401, and so on. So our student IDs, should the student IDs be unique in the student table? Right, so we don't have any two same students like repeating in the student table, and we will not have any two rows with the same course ID in the course table, because course ID is a primary key. Now, we said, okay, each student can take multiple courses. How can you design that in like your tables in a way that can handle many-to-many relationship? So there should be a common field here, right? Either you should use the course ID as a foreign key here, or student ID as a foreign key there. So in both cases, you will end up with multiple values stored in one cell, right? Because if you have like course ID here, then you will end up with Mona. So you have course ID here, right? This will be your foreign key. Now, maybe I got like many courses, like 3421, 3401. Am I allowed to have a table like this? No. So this doesn't work. And what about if I have like the students here? Again, it doesn't work, because this course have many students enrolled in this course, right? So again, you have multiple students here, and you're not allowed to store data like this. And so because this is not in the first normal form that I'm going to explain in the next session. So we are going to talk about normalization, and we'll see that we cannot have multiple values. But for now, like last session, we learned that this is not a relational table if you have duplicated rows. Second, if you have multiple values stored in a like single cell, like what you have here. Third, if your data type is not consistent. For instance, if your data type here is integer, if you define a student ID as an integer, you don't want to see string here, right? So what should we do? We said, okay, we are going to introduce a intersection table or associative entity, another table here between like these two. So this relationship is going to be converted. Even if you don't do it in ERDPlus, I already show you that it does convert it to, like when you, if you keep it this way in ERDPlus, many relationship, if you keep this relationship as it is, then when you convert it to relational schema, you will see that it adds a table for enroll, right? It doesn't do it for all the relationships, but if the relationship is many to many, the ERDPlus automatically converted to a table. This is because your design was not correct. It had to be an associative entity here because all entities are going to be your tables and not the relationships, right? So we treat that as an entity. Now, okay, so I put it as associative entity here. Like here, it makes more sense if you like have it as enrollment. Now, we said the enrollment, associative entity enrollment would help you get rid of the many-to-many relationship. It produces two one-to-many relationships, right? So one of these one-to-many relationships is here. The other one is here. Now, the relationship between a student and enrollment is one-to-many. Why? Why is it one-to-many?
Because for all the courses that student is enrolled in, it's only the single student that is enrolled.
So for each, you have to explain it this way. So it have to, like for each relationship, for instance, for the relationship between a student and enrollment, as I mentioned before, you have to explain it both ways, right? So one is between student to enrollment and the other from enrollment to a student. What does it mean? You say, okay, each student can take many enrollments, right? You can enroll in 3401, you can enroll in 4 to, I don't know, some other course codes. But each of like these enrollments are only associated with one student, okay? So each enrollment associated with only one student, but each student can like take many enrollments, right? Now, put it this way so that we have a space for the relationships. So is this relationship, what is the participation here? So is it mandatory or is it optional for both ways? So for instance, can a student take like no enrollment? Can a student like enroll in no course? Yes. So this is optional. And for each enrollment, if enrollment already happened, means that there was a student taking it, right? So it should be mandatory here. And then what about the course and enrollment? So you see how it is like a one-to-many relationship, right? So this is a one-to-many. And now on this side, again, we have the same thing. So you have the course here, right? Now, each course can have multiple enrollments, right, from different students. So, for example, for this course, let's say 3421, we can have enrollment that is specific to Mona, another enrollment by another student, and so on. So here again, we have a one-to-many relationship. So let's say each course has or contains or whatever that makes sense. Each course can have multiple enrollments, but each of these enrollments are related to only one course, right? So this is one. And in terms of participation, is it optional or mandatory? Like each course can have 0 enrollment. If this is your assumption, this is optional. But if you say that each course should have at least 1 enrollment, otherwise the course is canceled, then this will be mandatory. And if enrollment happens, so we also have a course. Now in the enrollment table, you better see and understand how this works. So in the enrollment table, I said whenever you have an associative entity, it should have at least 2 attributes. And what are those 2 attributes? What are the 2 attributes that an associative entity should have always? Yeah, the primary keys of the 2 entities that it's connecting to, right? Because whenever you want to connect 2 entities, regardless of the type of the relationship, always there should be a common field. For instance, forget about the enrollment for now. If you wanted to connect the student to the course, we said you either should have put the course ID as a foreign key here, or vice versa, a student ID as a foreign key there. Similarly, for example, if an employee is working in a department, the example that I mentioned several times, so we said department ID which is a primary key in the department table, will be a foreign key in the employee table, right? Because you want to see which department each employee is working in. In that case, we could do it because it was a one-to-many relationship. So for instance, here you had an employee, right? Here you had department. Now assuming that each employee can work in only one department, and each department can have at least 1 or more employees. Okay. Sorry. So in this case, and here we have employee ID as primary key and some other attributes, and here we had department ID as primary key and then some other attributes like the location of the department maybe, or names and so on. Now we'll have a table for the employee. What are the fields or the columns of the employee? We said that when I was talking about the relational model, we said that you will convert each entity to a table, and you will convert all the attributes to the columns of the table, right? So if we have an entity employee, we will have a table called employee. And if employee entity has attributes such as employee ID, employee first name, last name, and so on, then we'll have employee ID column here, then employee first name, let's say, last name, and so on. And here we have the same thing for the department. So we have the department entity, which is going to be your department table. What are the attributes for the department entity? Department ID, which will be your primary key. And then you have maybe the department name, location, and so on. And so this was a one-to-many relationship, right? In this case, because it's a one-to-many, we said that you didn't need any associative entity, and you can have maybe department ID as a foreign key here. And I also explained why we are adding department ID here as a foreign key and not a student ID here, right? Do you remember? So hopefully you can answer me now. Why can we add the department ID to the employee table here, but the employee ID cannot be added to the department table as a foreign key? Yeah.
In one-to-many relationship, we add the foreign key in the many side, right?
Yeah. So we always add to the many side. And why is that? What would be the problem if we add it to the one side? Let's say I have the employee ID, I add the employee ID here. So we have department IDs, let's say department, I don't know, 1, 2, 3, 4, and so on. And then here for the employee ID, we have 1, 2, 3, 4. And so on. So the employee IDs, employee numbers are unique here. So we cannot have two employees with the same employee ID. Here, department IDs are unique. Now, if you're going to add the employee ID here, what would be the problem? In each department, there are more than one employees. And that is the reason why you're always adding a primary key of one entity that is on the one side to the many side as the foreign key. Okay, so always foreign key is added to the many side of the relationship, which is the employee here. Because now each employee can only work in one department, right? So this way, maybe these two. This one maybe works in department 4. And there is no problem that department ID is repeating here, right? We can have two departments with the same ID in the employee table because department ID here is working as a foreign key, not a primary key, okay? Foreign key is just for linking the two tables. It's a common field that is just connecting two entities or tables. Now, back to our example there. Back to the example for the students and the course. So we said for the enrollment, we should have at least 2 attributes. Because enrollment is connected to 2 entities, a student and course, so always associative entities are connecting to 2 entities, right? So they should get the primary key of those 2 entities as the foreign key in themselves, right? So here, for instance, enrollment is connected to course, so this is a one-to-many relationship. The foreign key is added to the many side, which is the enrollment, right? What would be the foreign key here? The course ID. So here, for example, you have the course ID as the primary key, will be the foreign key here. Same here, a student number here was a student ID or student number was your primary key here, which is going to be added to the many side of the relationship as the foreign key. Now, these two together can form your primary key in the enrollment table. And what do we call it? When your primary key consists of more than one column. Composite, yeah, composite primary key, okay? So composite primary key is a primary key that is not just one column, maybe 2, 3, or more. Now, in the enrollment table, we have the a student ID, we have the course ID, we have maybe the grade of the student, and so on. Now, let's say student ID is 1, 2, 3, right? And this student was taking these 2 courses, 3, 4, 2, 1, 3, 4, 2, 1. Again, the same student is getting another course, 3, 4, 0, 1. Next student is 1, 4, 5, is taking again the same course. Another student is taking maybe these courses. And so on. So, as you can see in this table now, we have student IDs that are repeated, and that's no problem because a student ID in the enrollment table is just a foreign key, it's not a primary key. So we can have 2 students in the enrollment table with the same ID. That's because we can have multiple students enrolled in like a course, right? So we have, for instance, for each of like these courses, we can have multiple students and vice versa. So each student can also be enrolled in multiple courses. For instance, this student is enrolled in these 2 courses, then this student only this course, and so on. For each of the courses, again, they could be repeated because we can have multiple students. Now, can like two of these together, can we have a student ID and course ID appearing 2 times in the enrollment table? Like, can I have 1, 2, 3, 3, 4, 2, 1? So can I have like this here and again this here? No, right? So that was basically what we've covered so far. For instance, here we said that what are the example of a relation and what is not a relation. We said that each relation is a table, but each table cannot be a relation because, for instance, we may have a table with duplicated rows with multiple values stored in one cell, but that is not the definition of a relation. And here we said if you just like change the order of the columns or the rows, it doesn't matter. So you still like your table or relation is the same. We talked about different types of keys like a primary key, candidate key, a composite key, surrogate key, and so on. So let's review that. What was the candidate key? Yeah. Any attribute that can uniquely identify each rows can serve as a foreign key. Like for instance, we said an example about a student name. Maybe in your current relation or table, you don't have duplicated names for students and all student names are unique. And say, okay, so why not just like having the student name as the primary key? So a student name is a candidate key because it can uniquely identify each rows, but it's not going to be a good primary key because later you can insert a student with the same name. And we also said that it's better to always have like these integer kind of primary keys because they are like faster and better to work with. They're more efficient. And concatenated key or composite primary key is just a primary key that have more than one column, like the enrollment, right? Enrollment has a composite primary key. And surrogate key, I said sometimes you may not find a good primary key in your current table, so you can use surrogate keys that are automatically generated by the RDBMS that you're using, like you're using, for example, a SQL server, and you can just add surrogate key, which are just these numbers automatically added, like unique numbers for each row. And foreign key, a primary key in another table, it is going to be used to connect two entities together, right? We also said how we can connect, convert the ER model to relational schema. Now we also explained this, that why we cannot like put the employee ID as a foreign key in the department table. And this example, again, the same. I also wanted to just add a point about the multi-valued attributes. So we said that when you have multi-valued attributes, like ERDPlus automatically convert it to an entity for you. But it's not always the case that you want to like convert multi-valued attributes to an entity, because it depends. Most cases, yes, they become a weak entity. But in some cases, if your database is just very simple and that, for example, attribute that is multi-valued attribute has fixed values, like for instance, true, false, like 0, 1, something like that, that they are always fixed. So in that case, it would be okay if you convert that to an entity. Now let's go to ERDPlus. Do you all have access to ERDPlus? So let's practice this together. So a registration example that we were talking about. Now let's say, okay, what if we want to have, what if we want to design it in a way that each course also have several sections? This is the question that your friend asked the other time, okay? So how do we design it? Do we have any volunteer to work on the ERDPlus together? No volunteer? I will help you. Yeah. So you all can just go to ERDPlus, and then we just say, so you can just also create the folders, the new folders if you want, and then adding a new ERD model here. So, okay. So we can add entities. So what are the entities that we need? Let's start with the business rules first. So our assumption is that each student can take multiple courses, right? And for each course, a student can enroll in a specific section, right? For example, you are enrolled in section M, some people enrolled in section N, and so on. So courses have different sections. And so we need an entity for section or not. If I say each student can enroll in multiple courses, and a student can enroll in different sections, so how do you design that? We said, okay, each course can also have sections. So let's say you have like these course sections as a separate entity, okay? If you, no, you can continue just explaining, yeah. So in that case, we said, okay, each course can have multiple sections. For instance, database can have section with 1, 2, 3, so on. And each section, what could be the relationship between section and course then? Each section is only for one course. For example, if we have a database section N, this is for example, that is our assumption just to keep it simple, okay? Another way to do that was if you wanted like to keep the way that currently works in our university is better to have it as a separate section, and I'm going to explain separate entity, and I'm going to explain it later, rather than having it like as an attribute for the course, okay? So let's say we have a section which has a section maybe code or something. And then for this section, we can include many information because students are enrolled now in the sections of the course, right? Not the course itself. If that is the assumption, we are going to connect the student to the section, okay? And in the section, we want to see, for example, what is the schedule? For example, what is the start time for which day, for example, this section is. So we can have day of the week, for example, as an attribute. What else could we have? We can have the time, start time, end time, or just start time duration of the class. So we can have like time. What else? Seats. Number of seats. So you can have several information, but the most important ones like this, or for example, maybe the building name, right? So for instance, this could be another attribute. We can have room number, and so on. So there could be several things that we can have. What other attributes do we have? What other entities do we have? We have also entities for the instructors, right? Or professors. Now, for the instructors, what are the relationship and what are the attributes? For the attributes, we can have like his employee ID or like let's say an instructor ID, which is unique, and then it has a name. Now this name is a composite attribute, right? Because it has first name and last name. So this is a composite attribute which has first name and last name. And so it could have all other things like its affiliation and so on. Now, what is the relationship between, for instance, instructor and the course? So should I connect the instructor to the course now that we have the section, or should I connect it to the section? Section in this case makes more sense, right? So it again all depends on your design, but like most cases, like the case that we considered right now, it's better to have it like connect the instructor to the sections. And it's because, for instance, in this case, you say, okay, each instructor. Now let's assume that instructors can teach multiple sections of the course, right? So for instance, for a course like a database, maybe I'm teaching one section, another instructor is teaching another section. So it's more relevant to connect it to the course sections, right? Whereas if you connect it to the course, then we have multiple instructors teaching like different sections. So what is the relationship if each instructor can teach multiple sections, one section, and for section to the instructor, what would be the relationship? One to many, right? So for instructor, how many sections? One section. So you assume that each instructor can only teach one section of a course. So if your section, assuming that your section is a weak entity depending on the course, so I'm going to convert that later, because we said we are assuming that it's like this. For example, database section M, database section N, and so on, okay? And then we said each instructor can, like, for example, teach this section, right? So this is one in your table, and but can also teach other sections that are, for example, first of all, some instructors like me can teach multiple sections of the same course, so the relationship from this side is many, right? And second of all, maybe I'm teaching one section of this course, but another section from another course, okay? So instructors can teach multiple sections overall. So by section, you can assume a class that we are teaching, okay? So I'm teaching a class of a database. Another instructor may teaching another class of a database, okay? And in each of like those classes, right, or sections, how many instructors do we have? Only one, right? Because right now in the database in this section, I'm the only instructor. So this is one. Now, should each class have an instructor? Is it mandatory? Yes. Now, what about this one?
Optional.
Why optional?
Because professors doesn't have to teach any particular class.
Yeah, we can have instructors or professors that are not teaching anything, right? So if that is your assumption, then this is optional. And you can add also, and we said now we have to, okay, so we said also we have students now. So what are the relationship between a student and other entities? So now that we have like these course sections, which are our classes, right? We can actually directly connect a student to the section because section is already connected to the course. So first, let's connect these two together, so better clarifying everything. So what is the relationship between between the course and the class or sections of the course? So let's say each course, let's say a database course, can have multiple sections, right? Database section M, database section N, and so on. So each course, like another course, AI course, can also have multiple sections. These are your sections, and these are your courses, right? So these are your courses, these are your sections. Now, each course can have multiple sections, but each of like these sections are related to only one course. And the definition of these sections can only make sense if you have a course, right? So for instance, we have, for the Python course, okay, for the Python, what are the sections? They are A, B, C, D, okay? For database, we have M and so on. Sometimes they may have overlap. So the way that I'm showing them right now is like having maybe database M, database N, and so on. So each course can have multiple sections, right? Should a course have at least one section, right? Yes. So this is mandatory. Now, for each section, how many courses do we have? So for each of like these sections, this section is only for the database course and only one. Because we cannot have a section if you don't have a course, right? So this actually qualifies section as a weak entity, right? So what is the definition of a weak entity? It doesn't have a primary key of its own, okay? So it cannot, for having like a primary key, it depends on another entity, okay? So this is one definition. Or you can think of it as an entity that doesn't exist, so for its existence depends on another entity. So sometimes, again, depends on the context. Sometimes maybe you have some categories in the products, okay, that doesn't exist if the product doesn't exist, okay? So category in that case, product category could be like a weak entity that depends on the product. But we will also see an example today. I'll show an example which product category is not a weak entity. And again, that depends on the situation. Like for example, if you are working on a model, let's say on a website, that product category can exist even without a category. Like for example, they have sections for electronics, for toys, for several categories. Even if there is no product there, the section is still exists there. So if that is the case, then it could be like a regular entity. Now back to the example, we said that now we want to connect a student and the section. So how can I connect them? What is the relationship between a student and a section? So each student can have multiple, can take multiple sections or classes. You can think of it as a class too. So a student can like enroll in this one and maybe this one or this one, right? So can have like multiple enrollments, and each of like these classes can also have multiple students that are enrolled in them. So that's a many-to-many relationship. So we need associative entity here. So now you have the enrollment as an associative entity between these two, right? And now the relationship will be, I'll just remove this for now, just to make it more simple. So this is one, this is many, and also here, this is one, and this is many. And what about their participation? Is it mandatory or is it optional? So for each section, we said that, or each class or course, we can have several enrollments. Can we have a course or a section with no enrollment? No, doesn't make sense, so this is mandatory. And for like the other side, for each of like these enrollments, there should be like a section, right? So if we had an enrollment, so we had these two. If we had an enrollment, it means that there was a student, right? And what about this side? Can a student have no enrollments? Yes, so this is optional. So is there anything that we can add? And whenever you like, I'll add it later, just to make it more complex. So maybe we can also have a department, right? We can also have a department. And we have a department ID as the primary key, department name, department maybe location or building, and so on. So what is the relationship between instructors and the department? What's the relationship between instructors and department? Yeah, so they have what is the relationship? Instructors works at department. So each instructor is working, we assume that should work in one department and only one department. And each department should have at least one instructor, but can have also more instructors in it. So it's one to many. Could they have another type of relationship? Like, could these two entities have more than one relationship that we see here? What is another relationship that instructor can have with the department?
Maybe an instructor is the head of the department.
Yeah, if instructor, some professors are also like, for example, chair of the department or manage specific departments. So there could be another relationship here. If an instructor is also managing a department. And now, what is your assumption here? If I say each instructor can manage more than one department, but each department should be managed by only one instructor, is one too many. But in most cases, that's not the case. Each like professor maybe manage only one department, right? And is it mandatory or optional? Yeah, optional, because there are some instructors that are not managing any department. A department are also managed, let's say, by one instructor or one professor. They only have one, assuming they have only one manager. And then, is it mandatory or optional? Mandatory. Like we cannot have a department without the manager. So we have we see different types of entities, relationships. We are seeing even more. Maybe let's also see a super type, subtype of relationship. So you have here a student ID or a student number, which is the primary key, and a student name, which is composed of first name and last name. And now we can have different types of students, right? We can have international students, we can have domestic students. So this is, I think, shown like this. Not sure exactly, but something like that. And then it goes also into two other entities. Now, these subtype entities, which are here, let's say, international and domestic student, they all share the same attributes with their supertype entities. So, for example, a student have a student number, name, so on. So they all share the same entities. You don't need to draw it anymore, but they can also have their own attributes. So, for instance, for international student, we may also need which country he or she's coming from, what are their documents, or so on. And for domestic, also some other information. And yeah, is everything okay here?
So how do I make a composite entity?
Composite entity. Yeah. So when you can at first delete this one. So you add another entity here. Okay. Now that you add the entity, you define it as an associative entity, right?
Okay.
Now it depends if you want to, like with this design, we want to have like this enrollment connected to the sections of the course, right?
Yeah.
Oh, where's the course? Okay, here. I'm sorry. So what was the relationship that I deleted? So this relationship should be between the section of the course, right, and a student. So this is what I wanted to do for now. And this is one many-to-many relationship. So a student and enrollment should be here. Sorry, so this should be between section and enrollment, one of them, and enrollment, right? And then another relationship here between the student and enrollment. Okay, like this. So we added a composite or associative entity here, connecting the sections of the course to the student, because students can enroll in multiple courses or such sections of the courses. And for each course sections, like database section MN, there are multiple students that are enrolled in. Because that was a many-to-many relationship, we added like this composite or associative entity. Now this should have also shared the primary keys with these two, right?
Yeah.
So for
Section
instance,
ID.
yeah. So here we have a student ID. What are the adding the attributes? So it's a attribute name, a student ID. Okay, student ID. And then we also add another attribute, which is the section maybe. Here we also have to add an attribute for the section, maybe code or number or anything, right? Which works as the code. This is partially
So identify the primary key of the
course, right? When we have database section N, right, or section N, it depends on also the course ID. There is a relationship between course and section, right? So for instance, each course can have multiple sections, but each section is related to only one course. So we add also a relationship here. So relationship here could be like contains or have. Now, this should be an identifying relationship. So this is one thing that I just didn't show you before on ERDPlus. So when you have a relationship, you see there is a box here for identifying, okay? So this identifying relationship, you only click it when you have a relationship that is connecting a weak entity to its parent entity, okay? That is called an identifying relationship. So if I now click on this, you see that this is also double oval, right? So this is connecting the section to the course. So one entity here is the course, connecting to the course sections, right? Because each course now can have multiple sections. And each section is related to only one course, have many sections, and each section is only for one course. And if we have a section, there should be also a course. And Each course cannot have 0 sections, so this is also mandatory. So this is more obvious now. Now the relationship between the section and enrollment is that enrollment has, I can maybe takes enrollment. Now, you also always please do not forget to identify your unique identifiers or primary keys for your entities. For example, a student, so you correctly identify these, but just please select this so that it's unique identifier. For the enrollment, we have a student ID, but we also have to add another attribute for the section. Now, section code and a student ID together in the enrollment table work as a primary key. And we can also have a grade maybe here for the students in the enrollment table. Now for the course, we have the course ID, which is unique. And then we can also have maybe course name, right? We can also have the course name. And yeah, we can then continue from here. So we also mentioned that the department and instructors can have multiple roles. So one role relationship could also be managed. So we can also add another relationship, adding the instructor to the department. Let me delete this one too. Oh, we also didn't define the type of the relationship. So here, the type of relationship between enrollment and section, we already explained. So we said that there is one-to-many here and one-to-many here, because each section of the course, like database section M, can have several enrollments, like maybe 100 enrollments for this section, 100 enrollments for another section. So it can have multiple. Each section can have many enrollments. And we say that if we already have a section for a course, so there should be at least like one enrollment. So this is mandatory. Now, if there was an enrollment, there was also a course section. So this is 1, 3. And then here, for the student and enrollment, each student can have multiple enrollments for several courses, right? So this is also, a student can have many enrollments, but it can also have no enrollments. So this is optional. And then for each enrollment, I already showed in the enrollment table, we have something like this, right? I said each student can have multiple enrollments, right? So for instance, this student can enroll in multiple sections of like different courses, right? So this can be repeated. And the same is also for the sections and enrollment. So in the enrollment table, you can also have different course sections that are repeated. And that is why here you see that each section of the course can have multiple enrollments, right? And this is a one-to-many here. Okay, thank you so much. Thanks.
Thank you.
Okay, so we also add another relationship here that we said is managing the department. This is the relationship between the instructor and the department. And the relationship was one-to-many again. So we said that each, did it find it one-to-one or one-to-many? So if we say each instructor can manage only one department and each department can only have one instructor, then that is one-to-one. But if you think that, you can think like 3 ways, like each, maybe also each department have more than one managers. You can say each person may be managing like a couple of departments, but here we keep it like one-to-one. And instructor can manage no actually department. This is optional, but each department should have a manager. So this is mandatory. So I think this should become somehow complete, right? Do you have any question? And then here for the subtype, supertype, you can, when you want to like define the subtype entities, you just click here, add subtype entity, and then it automatically add this. Okay, so add another one, and then you can have like names for it, like international student or maybe domestic student. So is this clear? So now that we've worked, like, do you have any problem or question regarding working with the ERDPlus? How to? So by now, I expect you to be able to define the main entities for any like scenario, defining associative entities whenever there is many-to-many relationship, being able to define at least like the primary attributes for each entities, identify the primary keys whenever it's like need a composite primary key such as associative entities. Associative entities usually often, I think they always have the composite primary key, but you may also have composite primary key in other like regular entities as well. So you should be able to like do this, and even identifying the weak entities. If it is a weak entity, you should also define the relationship as the identifying relationship. So weak entity, you define it by double lined rectangle, and the identifying relationship is a relationship that is connecting a weak entity to its parent entity. Okay, and is again identified by double line oval. Yeah.
I have two questions. The first one, when we add new attribute for any entity, then like we're gonna see four attribute properties or types, right?
So for instance, let's say I'm on the course.
Yeah.
Okay.
Add like an attribute to that entity.
Okay.
Yeah. So we see like 4 or 5 types, right?
Yeah.
If we did not select any of those types, then what the terminology to describe that attribute? Like how to describe it?
It's you don't need to design. If it's just like any like non-key or normal attribute, you just leave it as it is. If it's like a primary key unique attribute, you define unique. If it's a multi-valued like full number, you define like multi-value. Some attributes are optional. Maybe like it's a description, you want to like have it or not, it doesn't matter, so we can like have optional. Composite and derived I already explained. So composite attribute, if it's like a name or address that is composed of several other components, then it's a composite attribute. And derived attribute if it's calculated based on other attributes. Okay, so most of the time you're only working with, so for all entities you have the unique one. So for all entities you have to use at least one unique attribute. Multi-valued and composite, I would say, are the most maybe common ones that you may see, because for instance, for most of the cases we have name, address, and they are composite attributes. But you may not see a derived attribute like necessarily or like optional. It depends. And if it's like none of them, just leave it as like this.
And the other question is why we have one-to-many relationship in like between the course and section. Like sometimes I like if you see the table here, we have DB, AE, and the other one, right? So with like I mean, at York we can have DB section M, and we can have AE section M.
Yeah.
So we can have like I mean multiple section, or like I mean we can have the same section for multiple courses.
That is why I mentioned like DBM and not just ABCDMN. So because that even get it more complex, and I wanted to explain also the weak entity and how we can have like the course section as a separate entity. So I just didn't want to make it even more complex. So I said, okay, let's say we have, for instance, DB section M, DB section N. Okay, other courses may have section M and N, but then that would be maybe ML section M, MLN. Okay, so that would be the section code. Okay. So in that case, the relationship is one-to-many because each course, like database, can have multiple sections, like database section M, N, etc. Or for example, Python course can have section A, B, C, but each course section, like for example, Python ABC, right? Python A, Python B, Python C is only related to the Python course, right? Or for example, DB section M is only for database course, it's not for like machine learning course, right? But if you have it, define it as like A, B, C, D, E, M, N, then yeah, maybe machine learning course has section M, section A, B, and then another course has also section A, B. Yeah.
Would it be equally valid if we try to do the same thing. Instead of defining it as a weak entity, but defining as a subtype of the course.
Define what as a subtype of the course? Section, you mean?
Section, yes. The section as a subtype of the course.
Just I wanted to mention that you have like different types of something, some object. Like for example, employees that could have like different types of employees, okay, in a department. Or if you have different types of a student. Or if we have an athlete that have different types of athletes. So they are, most of the time, in most cases, we use like this super type, subtype when we have different types of the same object, like employee, student, or whatever.
So for example, international student is a subtype, right?
Yeah.
Is that a column in the student table? Or like how does that work in this situation?
We can convert it to relational schema and see how does that work. So let me go back to the documents, convert it to relational schema, and then okay, just wanted to be more clear. And let's zoom in so that you can get it here. Can you see, or should I further zoom in? Okay, so whatever entity that you define in your ER model, regardless of the type of the entity, whether it's regular entity, whether it's associative entity, or like weak entity, any type of entity will become a table in your database later, okay? So I also showed you, even if you don't convert many-to-many relationship, it will add a table for you, okay? And here is the same. So when you have a super type like a student and then subtypes, it automatically add 2 more tables for you. So in your relational schema, so you see that you have. But in general, like later when you want to design your database, your real tables, it also all depends on you, that you see whether you really need 2 separate tables for like these different students or not. And it depends on what type of information, different type of information each of like these 2 sub-entities may have. So that may like maybe make more sense for like types of employees, because then for different types of employees there might be many different things in a department. So maybe yeah, you want to like store them in different tables. But this was just like a very simple example to show you how to add subtypes. So here we have, for instance, if you later you want to like store like many different information between like different types of a student, or they could like have different enrollments based on whether they are international or not, which is not the case. Yeah, that could even make more sense. But here you can just think of it as an example. So I have to quickly go to explain another example for you. So and can also be helpful for your project. So here you can see another example of the ER model for a sample retail company. So it's called Zaghi Retail Company Sale. You can also find this example in your textbook. So I put the reference here. It is for chapter 3. So here you can see, for instance, the main products that we have, the main entities that we have are, for instance, the product entity, customer entity, we have the store, transaction, you can think of it like the order that we previously mentioned. So these are the main entities that we discussed. So you can, it could remain the same for most of like e-commerce websites or any kind of businesses, right? So for all the businesses, you have some customers, you have some products that you want to sell, you have maybe some suppliers, you have some stores, and so on. And so you can easily relate this to your own assignment and also your project. And then you can see what are, for example, samples of the attributes. So for instance, we have a product with product ID as the primary key and the product name and price. Then we have customer, and we have orders or sale transactions, and so on. So here didn't convert the many-to-many relationship between your orders and products, or between your sale transactions and products, but you have to do it for your exam, okay? So you convert it and add an associative entity here. So each customer, just explaining the relationship that are in this ER model, each customer can have like place many orders or like can be involved in multiple sale transactions, right? But each of like these sale transactions or each of these orders are placed by only one customer. And let's say I'm ordering like a specific mobile phone, and then this order only belongs to me, okay? We are talking about the order right now and not the products, okay? Now, each of like these orders, now if I'm ordering, let's say iPhone 10, then this is my order which took place at a specific date and time and so on, can include also more products, right? So in one order, maybe you go to a website or an application and you order several products, okay? So your order contains several products, could be a phone, could be a charger, and so on. Or you want to order groceries, several grocery items. And each of like these products can also appear in several orders, right? So this is a many-to-many relationship. So you also have to include associative entity between these two. And then the relationship between product and vendor is defined as one-to-many because one vendor actually can supply many products, but each of the products is assumed that is produced by only or supplied by only one vendor. And then our sale transactions are happening at some stores, right? And those stores can located in different regions. Now, this you can have like different type of design here depending on how complex or simple you want to keep your ER model. So, for instance, if you didn't have like the region as a separate entity, in some cases that doesn't make any issue. So it depends on what type of data you have, what queries you want to later get, and how simple or complex you want to make it. But for instance, you always need the product, you always need the sale transactions or orders, you need the order line as an associative entity, you need like the customer. And for your assignment, you also have like different occasions, different categories for products. You have item add-ons, okay? So you also have to take care of those. And even though I mentioned you can make simplified assumption, so this happened in my previous class. So I just wanted to help the students not to overwhelm themselves with like super complex ER model. So I said, okay, you can simplify sometimes. So it doesn't mean that she literally put all the relationship as one-to-one, like even like simplest one. So like each customer can place only one product, each product can only be placed by only one customer, and each order should be like sent to only one place at by one recipient. So that is not, I cannot give you a full mark if that's the case, okay? So for your assignment, if you go to the flower shop, there are several like add-ons and so on and so on. Okay, some cases you may make simplified assumption if you see that your model is getting too complex, but please don't do it for every entity. I want to see at least one associative entity, weak entity somewhere. And that's it. Do you have any question? Okay, thank you.